Dialogues of Discovery, a platform where we bring you conversations with visionary thinkers and trailblazers who are shaping the future. If you are curious, passionate, or just figuring it all out, you're in the right place.
Each episode brings you insights, experiences, and advice from the lives and minds of remarkable people, scientists, innovators, and creators, so you can get inspired, explore, and start carving your own path forward. Listen on to uncover more.
Today, we have the pleasure of welcoming Dr. Shreya Santra, a space robotics researcher who works on autonomous robots and multi robot systems and co founder of Space Nova, a space startup. She has studied in India, Russia, and France and has gotten her master's degree in space and engineering systems from Skolkovo University of Science and Technology, Moscow, an experience she called independent, supportive, and innovative.
Dr. Shreya received her second master's from the International Space University, Strasbourg, and has been an active member of the Space Generation Advisory Council since 2015. She is also a recipient of the Japanese MEXT Scholarship and won the Caltech Space Challenge in 2019 and Micron UV Robot Design Contest in 2020. We are very excited to listen and dive deeper into her inspiring journey
Thank
today.
you, Professor, for taking the time out to have this conversation with us in spite of your busy schedule. Without any further ado, let's get started. We've prepared a few questions that hopefully won't just inform our readers, but inspire them as well.
So, to start off, could you tell us a bit more about how you got into space robotics? Was this like a childhood dream, or was it something that you realized over time, or was it like a sudden realization? How did it really occur to you that this is what you wanted to do for the rest of your life?
Thank you, Shikti and Pranati, for having me here for the STEM Chronicles. And a great question to start with. Um, no, space robotics did not happen to me from the beginning. It was not a childhood dream either. Uh, I did my bachelor's in electrical and electronics engineering first at NIT Jamshedpur, and then I went to the International Space University in France, where I got to meet people from many different backgrounds. So I was from electrical, but I was very much interested in satellite engineering or space engineering, spacecraft designing in general. But there I found people who were working on very different fields in space, like space science, astronomy, space business, space law, then also space art, and also space robotics was a project over there. And we had a professor coming from Japan, from Tohoku University, Professor Kazuo Yoshida, who came as a guest lecturer and introduced space robotics to us. And that's when I was like very much interested, like, okay, we can have robots on the space instead of humans, or along with humans, to work and do science and do, the difficult tasks. And that's how I got interested in robotics. And after that, I did a master's in Russia in Skolkovo Institute of Science and Technology in Space and Engineering Systems, where I was working on robotics. And then I went on for PhD at Tohoku University with the same professor, uh, Professor Kazuo Yoshida. And I worked on multiple robots, team of robots that can explore on the surface of the moon. And I continued there working as a faculty member. So I spent like 7 years in the Space Robotics Lab, working first as a PhD student and then as a faculty member working on space robotics. And it's a very, very interesting topic for me. I've learned so much about robotics, about how to make, these systems more robust, more safe for all kind of exploration, for science, and even for, services like on-orbit servicing of refueling, then repairing of other satellites. Um, I don't know if I'll be doing this for the rest of my life because there's so many things to do in space. But this is definitely going to be the prime focus of my work going forward.
So, you've studied in a lot of different places like India, Russia, France, and now Japan as well. So, with all these different experiences and these different places, how do you think, like, what was the main difference you felt between these different places, and how do you think each different experience shaped your current work right now?
My main passion was space. It was not like I wanted to explore certain places or certain countries or cultures. And that's why I went there. My main passion was like learning about space, and whatever opportunity came into my in my journey, I accepted those and I dived into those. And in the process, I learned a lot. Like I got exposure to several different cultures, different background, people from many different, countries who are all studying together at ISU, for example, and then Skoltech and Tohoku University. We had so many international members in our research teams, and that kind of opened my mind. I became much more holistic person of understanding how space is an interdisciplinary subject, first of all, and then if you are planning a space mission, you cannot just focus on one subject. There has to be a mix of many different subjects, and then you have to do a trade off of all the different systems, subsystems, and to make the system, make the mission successful. Like it starting from the economics, budget, the actual technical systems, then also you have to know the space law, where you should place your satellite, which spectrum you can use for your communication and everything. Like all these things are very, very important, and only get to learn when you interact with people from other background than yours. So all these places where I've been to, of course, the background, the culture of the people influenced me a lot, and that's something that has shaped me now. Knowing that I have worked with so many different people from so many different background, but also different attitude and behavior. So as a team member, I think I have evolved a lot to listen, and also how to put forward my own opinions and own knowledge in a respectful manner. So I think that's something that I have developed in myself.
I think that's really amazing. From going from robotics and just electronics engineering to actually space robotics and getting into all these different aspects of space. And like you said, you've been to so many different countries, from education to actually working in different countries. And you said that each one has shaped you in a different way, in made you into how you behave right now, how you work right now. And so um, that brings me to my next question, which is that you recently left the Space Robotics Lab after working there for 7 years, and you returned to India. So, how are you going to go forward, and what do you think prompted you to make that decision?
Yeah, so this was a long plan. Like the moment when I left India about 12 years ago, I knew I wanted to come back to India with everything that I have learned outside and implement it in India. So, but like as time went, I started getting a lot of opportunities and different scholarships, different offers of higher studies and then jobs. So I wanted to make the most of those opportunities, and I made sure like I learned a lot from everything that I was exposed to. I had the opportunity, so that's how I most importantly, because space robotics is a very niche topic, I did not just want to come back, after a master's or something. So I wanted to make sure that I make my presence felt in this field first, and do enough good work, get enough publications and projects done before I come back to India. So now, as I'm back to India, I'm looking forward to working in India in the academic sector, as well as a entrepreneur for with the focus on space robotics, mostly for orbital robotics and maybe lunar robotics, where I can develop with my team of students. I can develop projects and systems that can eventually go to space through the Indian space uh, companies or through ISRO. So that's my main goal in the next near future. And I basically want to build an ecosystem where, space robotics becomes everyday thing in the field, like, because people talk a lot about rockets and satellites, and SING should be for space robotics. So that's my goal.
So you said before earlier that you did a project on multi-robot systems where these different robots work together. And would you say that your projects, can you take us through a few of your projects since then? And would you say that they're extremely similar to that initial project, that they've all been shaped by that one, or that you've expanded into slightly more broader fields since then?
Yeah, so it started with multi-agent systems. I was always very interested in the challenging prospect of how we can coordinate between multiple agents and not just focus on one single rover or robot. So even for my master's, I worked on a combination of unmanned ground vehicle UGV and UAV, a drone that could work together and explore an area or do the task that they are supposed to do. For my PhD, I chose a multi-agent system that could coordinate with each other, communicate with each other, and explore a given area on the surface of the moon. So the main advantage of such a approach is that you don't risk losing your rovers to certain, risky areas, because they are communicating with each other and they know which places to go, and they have an idea of which places have been visited. So you also reduce the time that is required for the exploration. So for this, I basically develop a communication model where they can robustly communicate without much interference due to the different atmospheric effects on the signals. They could still communicate with each other and then make sure that they explore the area and do the tasks and go to the specific regions of interest that they are supposed to go without wasting too much time or without revisiting too much. Following that, when I started working as a faculty, I continued with multi-agent systems, but with new twist of having modular multi-agent systems. So by modular, I mean different type of functional modules, like arms, legs, wheels. So these kind of modules combine together to form different configurations of robots do certain tasks on the surface of the moon. So this project was like sponsored by the Japan Science and Technology Agency, and it's called Moonshot. So the idea was like to have these kind of self-evolving robots, modular self-evolving robots that can combine into different configurations, and they can form different forms of robots. Like they can look like a vehicle, some can look like a vehicle with an arm. So all these robots would be in different forms and they would do different tasks that are required from them, like for example transportation from point A to B. That would require a certain configuration of robot. Then another task could be like deploying communication towers or deploying solar panels on the surface of moon. So that would require a different kind of robot with an arm. So all these things require a lot of coordination between the modules and between the overall systems. So for that, I started working on these kind of robots and worked on the coordination part as well as the software stack of like the whole architecture of how these robots can choose which is the most optimum module that should combine together to form certain configurations and do the certain tasks that it's supposed to do. So, and the main goal of this whole mission was to set up lunar habitats. So we know like Now, just today, humans have gone back to moon again, more than 50 years, Artemis 2. In the next 5 years, humans will land on the moon multiple times, hopefully. In the next 10 years or so, we will have certain habitats on the moon so that humans can do certain activities, science exploration or, experimentation, whatever. So now we are going back to moon for good. We don't want to stop. And we want to be there, do the certain tasks, resource utilization, science experimentation. There are many minerals on the surface of the moon. So, but before we start doing all of that, it should be made safe. The surface of moon should be made safe for humans. So for that, we can have these kind of multi-modular, multifunctional team of robots that can be deployed there. And these robots can help in developing infrastructure of communication towers, satellite, solar panels, some habitats, where later the humans can stay and work. So that was the main idea of this project. And again, like my background of multi robot coordination and advanced algorithms for these multi agent systems were used for this.
You've clearly had like a lot of experience in the field, and it seems like multi-robot systems is kind of like your specialty. Like majority of the projects you've worked with seems related to like more than one robot system all working together to achieve the same goal. So, but I'm assuming that when you're creating a like a robot system or just a singular one for just one task, the robotics control is mostly the same everywhere. But when you're working for an environment like space, what are the things you would have to keep in mind and what are the things you'd have to think about differently? Because you might not be able to test everything accurately on Earth.
Yeah, that's a very good question. So definitely on Earth, we cannot, mimic exactly how the physics would be in microgravity conditions on the or on the moon, because in space there are many hostile uh, parameters like radiation, then microgravity, then micrometeorites, and also on the surface, if you go, then there is a regolith, which is very uncertain, and you can have your robot stuck there. So the only way we can do uh, up to some extent, 75 to 80%, we can test on Earth using different analog testing facilities, and we can test our systems as much as possible to prepare for what could happen. And initially, we start with simulations and physics based modeling. Then we move on to actual hardware testing in different fields, which are similar or up to some extent similar to how the surface of Moon or Mars would be. And then there are testings of thermal and vacuum chambers. Also, there are testing facilities where you can test different kind of microgravity conditions or hypergravity conditions like centrifuge or some gravity compensation systems. So there are many of these test facilities available both in India and abroad, and many labs also develop such kind of test facilities. In our lab also we had uh, test beds where we could test our wheel performance, how the rover is moving at different speed, if the rover is sinking or slipping in loose soil or in tight soil, if it's like moving very fast. So these kind of tests we can do, and we can make sure, like up to some extent, our system is robust. Then there's another approach which is very important, is to have redundant systems. So if our systems are just single systems, and so like a single failure point, then you basically lose your mission. but you cannot afford that because space missions are very, very expensive, and you cannot have them go on the moon and then just stop. Then, so you have to learn from previous missions that have failed and why they have failed, and then have certain redundant systems that can be like a backup if your main system fails. So, in case of like different suspension systems or different manipulator arm systems that can take up the task if the main arm fail or if the main camera is not working. So that kind of you know approach is very important, and that's also one of the advantages of multi-agent systems. So if you have a team of robots that you are sending to the moon or Mars, you don't have to depend on just one rover or one system. You can have like distribute the task among all these different teams of robots and then see how they perform. So that also adds system level redundancy if we have multi-agent systems. And um, and now with more advanced sensors, better controls, adaptive control, we have achieved that kind of reliability already in several planetary stuff, like planetary missions, as you can see, like Mars, Perseverance rover, with Ingenuity helicopter. Ingenuity helicopter was a very like an experimental mission, but it performed so well, and it actually helped in planning the path of the Mars Perseverance rover. So all these kind of things, if you have like multiple systems, multiple subsystems, it really helps in ensuring the success of the mission.
You said that there's multiple steps in this process of testing, even if you can't absolutely plan for everything. So you go from analog testing facilities to hardware tests and so on. And since there's so many tests, I'm sure that after you get to a later step, you'll realize something that you could perhaps do better in a step that you already tested, right? And you also said that there's been advancements in sensors, in controls, and how you learn from past missions. And so I'd like to know what are some of the advancements that have recently been made and that are actually being applied to missions that are coming up in the recent future.
Yeah. So in the present missions that are already in space, whether in orbital or planetary like Mars or Moon, most of the systems are autonomous. Autonomous in the sense they are automated programming. So they are given a certain sequence of tasks and they are supposed to do that with a human in the loop, where the human is constantly supervising, where they are going what they are doing. However, there is a gradual shift now where we are moving to a more, a more automated kind of instruction. So, like recently, the Mars Perseverance rover used a large language model to overcome this operator loop. So, the the sensors that are available on the rover, the cameras and other sensors, would analyze the environment, understand which place and which path is safe to take. And then this LLM would form like a middleman, which would give it the waypoints or the path that it should go to after every step. So this, instead of waiting for an operator on the ground to approve this, so every waypoint, every point that it should go, this LLM was doing the task. And then the higher level planner would follow that and control the actuators of the rover and move it to these next points. So this was very recently tested, and it shows like gradually AI based, AI driven decision making is also taking over, but still we cannot take big risks with space systems. So we still have a human checking whether the waypoints that are provided by the LLM is absolutely correct or not. So we do have someone, a human supervising the whole process, but the work of the human operator is reduced. And it helps because, when these operators are working on these rovers, which is so far away on Mars and Moon, they have to spend many hours just scrutinizing everything. But if a certain LLM decision making process comes in, it makes their work slightly easier. So that's what technology is. Like, we don't want technology to take over completely everything, but to assist the humans. So same goes for, computer vision, especially onboard perception of these rovers are pretty good already now, and it can do semantic understanding of the environment. So if it's a crater, if it's a rock, or if it's a horizon out there, so it's able to detect and take its and helps the LLM to take the decision accordingly. So gradually, these kind of things are coming in picture, and also for like reinforcement learning is being introduced where the rovers can learn from its experience and not do the same task where it can be penalized. Rather, it can get rewards for achieving a task that it should do. So, these things are like becoming more and more common, I would say, both on Earth, because on Earth, robotics is already very advanced, but in space, it's still nascent, but it's gradually growing and taking up the main, the difficult tasks that humans don't really need to do.
So, like following up on something you said slightly earlier, you said that even when the LLMs are guiding, which is and has not been tested as much, there's a human supervisor. So my question is that if the LLM gives it an instruction that the human supervisor realizes should not have been given, is it possible that the response sent by the human would take too long to actually be registered by the robot itself to stop?
No, that kind of fault detection and remediation is taken into account when we are designing the space system. So there's a full, you know, um, full study on risk management. So what all risk can you have if you are implementing a certain kind of system? So if you are implementing an LLM, you can have this kind of risk that you pointed out. So how do you mitigate this risk? And there you have to take into account that the human should, if there's a mistake done by the LLM, the supervising human in the loop should prevail. The decision of the human should prevail over LLM. Even if it takes time, the rover should be able to like correct itself and do the execution as per the supervisor would do. So this is important, and always like the human, because one thing that you need to understand is AI cannot take accountability of anything. It's the humans who are accountable if it's a space mission. So, like if someone's developed the LLM, it's not the LLM that's accountable of making a mistake. It's the person who developed it would be accountable. So no one wants to lose such expensive systems, and no one wants to be, accountable for the failure of these big missions. So definitely, there is this human in the loop where the strategic supervision is taken into account, and to make sure that it's safely navigating and safely doing the tasks that it's supposed to do.
So there are clearly a lot of different systems that are helping and forming the different parts of like the entire field of space robotics. And now I want to talk a bit more about AI. So you mentioned it also a couple of times previously already. And even though it's AI integration on Earth itself is at an all-time high, it it's pretty gradual in space still. So what do you think will be the different aspects or areas where AI will be the most beneficial, and which one do you think will need more development before they can achieve that kind of independence?
Yeah, so AI, we still need to develop a lot and test and qualify these algorithms properly for space. For now, the most advanced is computer vision, where semantic segmentation and instance segmentation is working very well on the systems. However, one of the major limitations of space systems is the power and mass. So you cannot have very heavy power systems on these robots. And also you cannot send like very big batteries or very big RTGs to the surface. So this becomes a major limitation, and most of the AI tools, AI training require a lot of power. Maybe you've seen different news of how the AI data centers are taking up a lot of power and water for cooling. So, but in space, we don't have these resources. So we have to be very economical on how we use the power. If the if like the algorithm and the framework, AI framework that we are using is taking too much power, we cannot have that on space until we set up the power systems on the surface of the moon. So that is one of the limitations. And so far, like if you want to, one of the things that needs development and needs, advancement is definitely the AI based control systems or more autonomous control systems where the robots can be adaptive and learn from their experience and from what they have done, and then based on a reward or penalty they can repeat the task that's supposed to do. But again, this training requires a lot of data. It requires pre-training a lot. So this is still a very advancing sector. On Earth it's already very well displayed on the robots, but on in space it still requires time to develop.
So moving away slightly from AI, and our blog this month's upcoming blog for April is about the feasibility of space colonization. And so you already said that we need to, for AI, we need to set up power systems on the moon. But how possible do you think, based on your work, that human colonization in space is actually possible? And what do you think we need to develop more first, that we need more advancements in before we can actually even start considering it and putting enough resources into that?
Yeah, as I mentioned earlier, like today we had the Artemis 2 launch, and it's a great moment to see that humans are going back to moon, and this time to stay to for good. So we will definitely have certain human outposts and small settlements on the surface of the moon for in situ resource utilization and for extraction of certain important resources that can help us further our space exploration, our space quest. I don't think colonization is a good word to say, like, because I don't think colonization is sustainable. Any colonies that you see, like on Earth, wherever there had been colonization, they did not continue for beyond 200 or 300 years. You don't have colonies anymore, so that's not sustainable. If we want to have a sustainable, reliable exploration of space, we should be very conscious and very respectful of what we want to do when we arrive on the surface of moon, and then when we arrive on the surface of Mars. And on moon we know there are a lot of resources. There is also possible to do a lot of radio astronomy, and Moon has a lot of fuel like um, O2 and helium-3 that can be used as fuel for further moving to Mars and beyond. So that should be the main goal. Like, how can we use these resources in a responsible manner so that we can sustain our space quest? Uh, there's still time to get to that level. I think now that we are going back to moon, I think it will take a few more years for humans to actually land on the moon, and then deploy certain robots that can do some preliminary tasks before humans settle. So I think at least 10 to 20 years from now, we might see some advancements in terms of small settlements. And then, of course, when we go beyond to Mars, we know that might had life earlier. We have several evidences that there was water on Mars, so it might have supported life, or maybe it will support later. Maybe it's still evolving. So we have to be very careful of how we explore Mars, because there can be certain bioorganisms under the surface, or there can be something that we are disturbing the ecosystem of Mars. So again, by when we go to Mars, have certain robots there, it's very important that we make sure we do not disturb this ecosystem that's already there on that planet. And yeah, it will take a lot of time, I think. I mean, it took us over 50 years to get to moon again. And now, but now we have several countries that are working towards space. It's not just US, but also China and India and several other nations that are going for the space quest. So it will be accelerated, but I think we should not hurry too much into colonizing or setting up, settlements aggressively. We should focus more on sustainability, developing energy efficient infrastructure that can help us establish long duration operations.
So essentially, we shouldn't exploit the resources that we find. So my question is that it's not exactly controversial, but there's no clear line, there's no clear distinction between at which point you begin to use these and begin to finish using these resources responsibly and start actually exploiting them. And so, how would you say that at which point would you say we've stopped using them responsibly and have actually started to waste them or use them for our own benefit as opposed to good?
Yeah, so at the very beginning, we should have laws that will enable us to extract these resources in a more sustainable way. Unfortunately, we don't have. The Outer Space Treaty just basically says that no one can own a land on moon, but how you extract and how you use that source is not defined. So as we go forward, as we have like more uh, human or robotic missions to moon, we have to be more conscious how the next generation is framing this whole uh, space ecosystem. And we definitely need like certain policies and laws that will restrict not exploiting the resources and have a more shared kind of economy where different stakeholders can share the resources that are available on moon. It sounds very utopian, but that's what we should do, because we see what we have done to Earth, in the last 20-25 years. The condition of Earth has really degraded with high temperatures, global warming, and a lot of problems. So we should learn what we have, from our mistakes on Earth. And I think people who are in the aerospace sector, that it's not a lot of people, there are very few. And gradually there are people coming in from the industry as well. So there has to be a consensus of how we can set up a shared economy and a sustainable economy for a strong foundation over the years. And only then we can make sure that we don't exploit the resources too much. So definitely here a lot of things come in like space law, space policy, and a policy which is equitable and fair to everyone, and also how the engineers and technologists use and follow that policy. So that's very important. So at the very beginning, I think policy is important to establish.
Yeah, that's actually a pretty strong opinion on space colonization, but at the same time, it's a very valid one because there is no guarantee that whatever how the way we use the resources is really going to be sustainable. But then at the same time, we humans have achieved so much that eventually we might be able to create small settlements on other planets that still are sustainable. And since we are talking about human achievements here and what all we can possibly achieve in the future, what is one thing that you have achieved, like one of your discoveries or creations that you would consider the breakthrough of your career, like something that stuck with you through your life and will stay with you forever?
Yeah, I think I'll go back to what I did in my PhD, where I worked on multi-rover systems for exploration in an unknown environment on the moon. And this project was inspired by NASA's mission called CADRE, CADRE, which is basically focusing on having three mini rovers on the surface of moon, and they are communicating using radio frequency communication and exchanging information of what kind of science they are exploring, which areas they are going to, and what obstacles that they are encountering. So this work, my PhD was very similar, and that's something now that this NASA Cadre mission has been approved, it feels like, okay, this my work is very similar to this, and I would like to, you know, say like, okay, this is something that I have achieved. Hopefully, I will be able to test it in the near future as well, similar to how NASA is doing. And that's something so far I think is has been a big achievement for me. And just have learning during that process and understanding how communication works, how powers work, how these distributed autonomy algorithms are uh, working, and just developing those kind of robust algorithms have been a very strong learning process. And I think it has helped me a lot as a technical engineer to develop different kind of critical thinking processes of how these multiple agents are operating in extreme environments. So I think that's one of my yeah achievements.
That's a really inspiring project. And I'm sure that everyone listening to this interview will think so as well. And it also might help them figure out how to, follow their own path. But at the same time, that could also seem, while it seems exciting, it could also be slightly overwhelming. And they might not exactly know how to move forward. So, what kind of approach or mindset do you think might help them to recover from that sort of slump in which they don't really know what to do?
Hmm. So I think like if students are interested in getting into the aerospace sector, there are a lot of opportunities now. There are many fields that they can go into. They don't have to only get into engineering, but they can also get into science and uh, law, policy. Everyone is most welcome in this space field. It's a very interdisciplinary subject, as I kept saying. But the most important thing is they should have a very strong foundation on what they are currently doing or want to do. Like if it's a school student, then and wants to go for engineering, for for example, then they should focus a lot on maths and physics. If someone's interested in space medicine, then they should focus a lot on biology. If they are interested in propulsion systems or some analyzing rocks and analyzing chemicals on the surface of on the planetary surfaces, they should have a very strong foundation in chemistry. So just like these are examples. So they should build a strong foundation on whatever they are learning now so that their journey and their path in, in the future can become more easier. They don't have to like decide what they want to do in the next 5 years or 10 years. No one knows because the world is very uncertain. You don't know what you're going to do in the next 5 years. I didn't know I would get into space robotics, but I had a background in electrical and electronics engineering. I was good in maths and physics. So I knew like I could learn these systems, these controls, the perception, navigation, and things like that. And I could evolve myself and keep learning more and more. Initially, I was very apprehensive of coding and programming, but as with time, I realized like you definitely need to know some coding so that you can actually build the systems. So these kind of open mindset where the students are ready to learn new things and have a systems engineering kind of thinking so that they can take in also what others are doing, like learn from others and and integrate that in their own work. That's very important. So I don't think anyone is in a slump or students are confused or anything. It's just that I think they are overthinking how and what they want to do in the future. But the most important thing is they know what they are doing now. So just focus on your present, do different and grab the opportunities as it's coming. Like if you're getting an opportunity to do hands-on training or a hackathon or participating in a workshop or a summer school, just go for it and learn new things so that you more and more opportunities open up for you. Is that what I would like to say? And aerospace field itself is a very like very difficult field. I'm not just saying about engineering, but in general, like all the uh, aerospace fields are difficult. But if you have the passion, if you're driven by passion, I think aerospace is a great place to be persistent and patient with your journey so that you can eventually, you'll reach there where you want to. For me, I don't think I've reached where I want to. I still want to do more and more work to make space more safer, to make robots which can help in the sustainable development of space exploration and settlements. So for me, it's still a journey where I want to learn more and want to impart the knowledge to my students and other people around me so that we can build a ecosystem for space robotics. So yeah, I mean that's my advice. Just keep being curious.
So I completely agree. Passion is very important when you're trying to pursue your choice of path. But like I know people, and at one point And sometimes I still feel like I'm some of those people who still don't really know what they really want to do in the future. Like they haven't really realized their passion yet and they don't know what really calls to them. So, what would be like one piece of advice you would give them to help them figure out their path forward and kind of realize themselves?
I, I again, like as I'm saying, I don't think we should think too much into the future. You don't have to think like you'll do space robotics or you will build a rocket um, in the next 10 years or so, in 5 years. What's important is now what you're doing and what you would do maybe in the next 2 years or so. So if you are now in your ninth grade or 10th grade and you're interested in certain subjects, just pursue that and build a very strong foundation in that. Make sure you are giving the best on the fundamentals and learning what is important. And then as you go forward, like eventually in 11th and 12th grade and then in college, you can explore more and more. Because once you are in college, I think it gives you a lot of opportunity to explore many different fields and many different paths. So you don't have to really like restrict yourself on thinking what you just want to do 10 years from now. It's not possible to think so far ahead.
I think that's great advice that you don't that what you're doing right now is a lot more important than always looking to the future. And that was our last question for today. So thank you so much for taking the time to speak with us, Professor. We really enjoyed our conversation and we've all learned a lot from it. And the stories you shared, your insights, your belief in the future of space robotics, it's all been truly inspiring for us, and I'm sure they'll inspire our listeners as well. Thank you.
Thank you so much.
Thank you for joining us today on this journey of ideas, inspiration, and innovation.
We hope this conversation sparked curiosity and reminded you that behind every great discovery is a human story of passion, purpose, and persistence.
Until next time, stay curious, stay inspired, and keep learning because the future is being built by the questions you ask today.
This is Dialogues of Discovery signing off.